Welcome to the second exercise in this exciting chapter. Today we're going to be talking about circumference, which is the perimeter of a circle. The last lesson we talked about perimeter, and the perimeter is the distance around a shape. The special name for the distance around a circle is called the circumference. It's also a perimeter. Now, let's get some circle terms understood. You can see the red line is the radius. When you're talking about a circle, the radius is a distance from the center to the outside of the circle, and it's always the same distance regardless of where you draw it. The diameter is the distance across the circle, making sure you pass through the center. A chord is just the distance from one point on a circle to another point on a circle. So if I actually drew this chord in, it's a chord. But because it passes through the center, it's a special chord, and we call it a diameter. Now, the circumference is the full distance around the outside of a circle. Sometimes we call it the perimeter. An arc is the distance around part of a circle. So that red curve there could be called the arc length. A sector, it's like a piece of cake or a piece of pizza. The sector is the bit in red. There are actually two sectors there. The bit in red is called the minor sector. Everything else is called the major sector. Now, some formulas. Both formulas work. You don't need to know both of them. You can survive with one of them. But if we have a circle and we are told the radius, the fastest way to find the circumference is to do circumference is equal to 2 times pi times the radius. If we have a circle and we know the diameter, the fastest way, instead of doing 2 times pi times radius, is to do pi times the diameter, because the diameter is 2 radiuses. So it doesn't matter which of the two formulas you use. I'll use whichever one is going to be the fastest. I'll use this formula if the circle has a radius. I'll use this formula if I know the diameter of the circle. Alright, here's our sector. What's the formula for the perimeter of a sector? Well, we need to look at this as two separate parts. I have two straight line bits, which I can write as r plus r, each of the two radiuses, or I could write that as two lots of r. But then I have the hard part, which is the bit to figure out the curved bit. Well, there's the formula. Let's think about this formula. 2 r's. That's the straight bit and the straight bit. R plus r is 2r. This part is actually the formula to find the curved part. Now, we know 2 pi r is the distance around a full circle. It's the circumference of a full circle. Theta over 360 means you're only going to cover this angle of the circle. So it's saying, instead of finding the distance around a full circle, only theta's worth of a third circle. And remember, theta is just an angle in degrees. Well, let's try finding the circumference of our first question. Now I know the diameter, so I'm going to use c equals pi times diameter. That's the formula to find the circumference of this circle, which becomes pi times 24, which is 75.4 centimeters if I round it to one decimal place. If the question said give your answer in exact form, I would have actually looked at that and said the exact answer is 24 pi centimeters. So if you get an exact one, you just don't put the pi in the calculator, you leave that in the answer. We go to example number 2, find the circumference. Well, this is a question where I'm given the radius, so I'm going to use 2 pi r as my formula. So 2 times pi times the radius, which is 5. Put that into your calculator, 31.4. If you wanted to get the exact answer, you'd go 2 times 5, which is 10. So it's 10 pi meters if you wanted the exact answer. Sometimes the textbook will say give an exact answer. Number 3, find the circumference of this particular shape. It's called a sector, remember? So our formula for the area of a sector is 2 lots of the radius. That means this radius and this radius added together. 2 of those, that's 3, and 3 is 6, or 2 times 3 is 6. The angle of my sector is 50 degrees, so that's going to go in place of theta, and the radius is 3 centimeters, because this is really a circle that if I draw a small sector, remember that it's just part of a bigger circle. So the radius is that part of the sector. So we put our numbers in. I know the radius is 3, I know the theta is 50, put that straight into the calculator, and the perimeter of that sector, or I shouldn't have used the word circumference there, because circumference is for a full circle. I should have used perimeter. The perimeter is 8.6 centimeters if I round it to 1 decimal place. Now, this is still a sector, but it's a major sector, a little bit like a Pac-Man piece. Now, because I want to find the area, the perimeter, and this is the part of the circle, I need the angle that's on this side. Now, I know a full revolution is 60 degrees. So a full revolution is 360 degrees. If that's 60 degrees, the remaining angle must be 300 degrees. So I can put that in, because 360 will add up to 360. So I know my radius now. My radius is 4 centimeters, so I'm going to do 2 lots of the radius. The angle I'm using is not 60 degrees. If I used 60 degrees, I would be finding the perimeter of that sector, which is not the one that I want. So let's put in 300 where we see theta, and we know the radius is 4. Plug the numbers into your calculator, and that will become 28.9 centimeters if I take it to 1 decimal place. Let's try another one of these just to make sure we get the hang of it, but I've added in a little bit of a trick. It says to find the exact value. So we've got the right angle. The angle 310 degrees is inside the section that I want to find the perimeter of. So there's my formula. I know the radius is 2, theta is 310. They're the values, but I can't put this into my calculator. Now I can do each part separately. This part here, 2 times 2, that gives 4. There's a plus there. Got to be careful with BODMAS. You have to do all the timeses first. So 2 times 2 is 4. Now when I'm focusing on this part here, I'm going to put it into the calculator but deliberately leave the pi out. So I'll go 310 over 360 times 2 times 2. And when you do that, we'll see what answer we get. So this first 2 times 2 gives 4. When you put 310 over 360 times 2 times 2, you get 31 over 9. So it's just 31 over 9 times pi. 4 plus 31 over 9 times pi is the exact value of the perimeter. You could actually find out the answer to a decimal place, but that's not what this question has asked. Right, now we have a bicycle wheel. We know the distance around the bike wheel is 310 centimeters. What is the diameter? Well, I have a formula to find the circumference of a circle when I know the diameter. Circumference is pi times diameter. If I know the circumference is 310, I can replace c with 310. Then I just divide both sides by pi, do 310 over pi on the calculator, and that works out to be about 98.7 centimeters if I round it to 1 decimal place. So, that's the end of the examples. It's now time for you to try some questions. Enjoy the mathematical experience. Bye for now.